The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Numbers Involving Zeros at the End. We have used many examples in the earlier sections of numbers dealing with zeros at the end. We can understand the impact of zero on the square root by applying the following simple techniques. The number ending with a single digit at the end can never give a perfect square. For example, consider the numbers 10, in which case the 0 is an odd digit. 1000, in which case the number of 0 is an odd digit. 100,000, in which case there are 5 digits at the end. These numbers never give a perfect square root. If you find out the square root of 10, it is 3.16. The square root of 1000 is 31.6, and the square root of 100,000 is 316.2. However, take the multiples of tens and hundreds having even digits at the end. For example, 100 gives a perfect square root 10, and 10,000 gives a perfect square root 100. Is it because of the number of digits at the end? Certainly not. In the case of even digit zeros at the end of a number, we have to take the remaining number excluding zeros and find out whether that is a perfect square or not. In the case of 100, when we exclude the 2 zeros, we get 1. That can be considered as 1 multiplied by 1. In the case of 10,000, if we exclude the 4 zeros at the end, we get 1, which is a perfect square. On the other hand, let us consider the numbers 200 and 30,000. Though the zeros at the end of the number are in even digits, 200 is not a perfect square. The square root of 200 is 14.14, and the square root of 30,000 is 173.2. This is because 2 in 200 after excluding the 2 zeros is not a perfect square, and 3 after excluding the 4 zeros is also not a perfect square. Let us take some more examples. The number 8,100 is a perfect square, not because of the 2 zeros at the end. It is due to the fact that 81 is a perfect square, as 9 multiplied by 9 is 81. However, 7,200 is not a perfect square because 72 is not a perfect square. If we take a 5-digit number such as 12,100, it is a perfect square because 121 is a perfect square, as it can be written as 11 multiplied by 11. On the other hand, 13,200 is not a perfect square. Therefore, whenever we get even digit numbers at the end, we have to simply consider the remaining digits and find out whether they are perfect squares or not. If yes, we just take those square roots and take one out of the two zeros and add it to the square root. For example, in 12,100, 121 gives a perfect square 11. Now we are left with two zeros, and therefore one zero can be added to the square root and making it as 110 as the square root. That is, the square root of 12,100 is 110. Let us take the number 1,440,000. Here the number excluding the four zeros is a perfect square, and the square root is 12. We can consider the full number which have four zeros, and therefore we can add two of the four zeros to the square root of 144, making it as 1,200. Therefore, the square root of 1,440,000 is 1,200. In using 5-digit numbers involving zeros at the end, we demonstrated that the square root may be a perfect one or one with decimals too. For example, the number 96,100 having two zeros at the end gives a perfect square root 310, whereas the number 53,600 having two zeros at the end is not a perfect square, and the exact square root is 231.52. The understanding of the above procedures will definitely help the child to reduce the complexity of the problem, especially in dealing with the numbers having zeros at the end. The problems dealing with the square root involve many operations such as addition, subtraction, multiplication, division, decimal point, etc. and therefore more exercises in this area will fine-tune the skills of the child in all dimensions of the abacus. And as a result, let us take some more examples to provide varied experiences to the child.